We are live. Give folks a minute to join here. All right. Hello. Good evening. I'm doing all right, Andy. How are you? All right. How are you, Cyril? Can you hear me? All right. Okay. So the recording is good. Can get sound and minimize that. All right. Let's see. We'll give folks just one more minute to join, and we'll get going. All right. Let's see. All right, the recording is good. The sound is good. And let me see if we can play some music while we wait for 1 minute. All right. All right. So, uh, so much for the musical interlude. All right. You guys ready to go? Excited? Can you hear me? All right. Cool, cool. Let's see. Let me just text Emmanuel to see. I sent a message to the group, so hopefully he got it. Okay, so he just joined. Um, the bridge is up, so I don't know if he's joined the bridge, but all right. So I got one assignment from Cyril. Andy, where's your assignment? Okay, sure. And then Emmanuel, if you can hear us, can you also upload your assignment? Okay. So while I wait, just go through sort of a brief outline of what we'll be doing today. Um, Effectively, we'll just review the homework. I presume we'll spend about 30 minutes on that. It could be a combination of reviewing some of our SQL skills and just trying to address where the needs are with everybody. Um, I have a general solution that I'll share with you guys. And in some way, I mean, if after the class you can review that to just confirm your understanding, that would be helpful. Um, then I'll just do a quick review of what we discussed last time in terms of the architecture of Oracle database. Excuse me. All right, we have to drink something. And then we will move on to perhaps one of the most useful and important skills you can ever have as okay. One of the most important, things you can ever have, skills you can ever have as a SQL developer is what basically is called PL SQL, right? Procedural Language SQL. Basically, you write like code. When you hear somebody who's a programmer, um, typically people think of the people who are writing code to behind websites, behind operations of automated systems, something that goes in, does something at a specific time, and then it stops, right? So it's a series of commands or actions that some program has to execute, right? Um, I see that as the last major hurdle or concept to explore in this intermediate class. So quick overview of the outline. So when we started off, what I had said was we're going to go through this sort of outline, right? And effectively, we are in session 5, right, which is supposed to focus mainly on the PL SQL. However, where we find ourselves is that there's still some concepts that we didn't touch on, and I don't think it's a big problem per se. So my proposal is that we will split up. We'll use half of Saturday's session to finish the PL SQL because PL SQL itself, um, I don't think we can cover everything today. It's perhaps not by accident that we find ourselves in this place because I don't want us to get out of this uh, experience and say, oh, well, we've learned all these concepts, but we have no idea how to use them, right? So how much should I take time so that you guys can feel comfortable writing your SQLs? Because that's the core thing you need to have, like to be able to kind of, somebody tells you a problem, can you solve, can you write a query to do this? I want you to be able to write it. However, I can't see yourself going to a SQL interview per se, where you have no idea what PL SQL is, or at least have an idea of the concepts or the core ideas behind that, right? So Then basically, once that is done, we finish this, then we'll resume our stock trading project, right? Which my hope is that to the extent you guys remain interested, uh, the subsequent courses we will take will continue to build on that, and hopefully by the end of I can see ourselves that by the end of maybe the fourth course in this series, if you're still interested, you should have something that guess what might actually be very useful to have as your own investment uh, analytics tool that you use to make your decisions as to what you buy in your retirement accounts and what some people actually do as a profession, right? So um, that's that's basically the general outline for today. Going back to the yeah, so we'll talk about the core concepts of PL SQL, and there's a core reference material, this link that I'm going to use for the PL SQL tutorial. It's actually one of the most concise links out there. It's kind of material is stale, but the PL SQL doesn't really change much. Okay, if you understand the core concepts, the rest is all just kind of brushing up and learning the newer features or newer tools that are out there. Okay, so all right. I presume somebody's uploaded a file. Okay, Andy, I see your file. Let me download that onto, uh, okay. All right, so I got solutions from Cyril and you. Emmanuel, I don't know if you're on the bridge. I still hear music on the bridge, so presumably you're not here yet. Um, be that as it may, I'll pull up, let me start with Cyril since he started his solution first, okay? Sort of a reward, okay, for submitting your homework early. Um, okay. All right, here we go. So, all right, so I see this, Cyril. You did use your comments, which is excellent. Let me actually open this profile. All right. All right. So, what was the problem statement per se, right? So, I do have it here. I don't think you guys can see anything on my screen right now. So, let me immediately share. Um, let me share the SQL Plus window, SQL Developer window. In both. Here's this one. Just stop this and share that. Okay. So can everybody see my SQL developer window okay? Cyril, can you say something again? I can't hear you. All right, so Andy, you can see it, but Cyril, I cannot hear you. All right, but we're going to start with yours. All right. Today's a slightly shorter session, so whenever you sort it out, the technical issue, just say something. All right. But as long as you can hear me, I think that's also good. I'm just going to review what the problem statement was and to basically highlight the key point I keep saying throughout our sessions, right? Which is that you need to really understand the problem statement because oftentimes with these technical jobs or technical, the main thing is your ability to pay attention, right, to what they're asking. And as Emmanuel will tell you, just listen to what he's saying, take some notes, and then go do some research and then get back to them with a solution. Hardly would you find a job where they want you to basically come up with technical solutions like literally on the spot all the time. Mostly it's project based, but you do well to understand what the project is about, document on the key concepts, and then you can use that to help solve the problem. Now, In fact, this assignment, the first question is much harder than the second question. Okay, um, but we'll take the first question and effectively, Andy, can you take your time to just explain to me what you understood by what the requirement was here? Right. So if we look at our employees table, right, every employee, right, has uh, some job ID, right, which tells them you're ADVP, IT programmer, whatever, all these codes. And I've given you guys a hint that there's a table there called jobs, right? And in that table, if for every job ID, it tells you the title, the actual sort of title, much more descriptive version of it, and the minimum salary and the maximum salary, right? So what I was saying was, okay, in this first piece of it, right, we are going to go find every employee, right, and let's see how much they make relative to this average salary of the people who have the same title. Okay. So I don't know if Cyril can talk, but I wanted to see if you could talk us through your solution. Can you say something, Cyril? Cyril, can you say something? All right. I guess it's still an issue. All right. So let me just pull up your solution, Andy, and then we will discuss that. Okay. So let's do this, that. Let me pull up. I did save yours in the assignment folder. Homework submissions and the S4. Okay, good. All right. So in effect, this is your solution, right? Can you walk us through it? Let me give you some control. Give me a second. I'll give you control to just Andy. All right. So Andy, just drive us through your solution. Yeah. Yeah. Right. Well, let me just interject you for a second. So you're trying to solve this problem, right? Which is, let me just paste the question to help with the explanation, right? Right. So you're trying to solve the first problem, right? Mhm. Okay. Okay. Yeah, I'm actually quite happy with how you approached it. Um, it's a bit of there's a couple of just minor issues, but it's the approach is actually right, in the sense that the question says, let's go find for every employee, right? How much they make relative to the people in the same sort of job title. So if let's say you're in an organization and you are, I don't know, they have five job titles, right? And you are whatever, vice president. We will look at everybody in the organization who is a vice president and find the average salary. And you try to compare yours with them, right? Because in general, that's the general thing is, for most companies, they will say, hey, for this job title, this is the minimum and this is the maximum salary. And they have to comply with that for sort of from a legal standpoint, right? So you want to make the argument that, hey, I want to compare what I'm making versus what the average salary is. And if I'm making above that, then, you feel like, okay, they value you more. Like if you are making less, you may have a case to say that maybe they end up paying you. However, it's not just always simple as that. Sometimes they will say for this job title, if you're in this department, then this is what it is. This is what the value is. In our case, the table that we are looking at doesn't have this jobs table mapping. It doesn't say that, oh, if you're in this department, right? It just says if you have this job title, then this is a minimum salary and this is a maximum salary, right? So if they had that extra level, then you have maybe another column to tell you. But so, like I said, this is a general approach, right? If there are a couple of things I would say, it's like, okay, so your solution is, um, if I find the average salary for people with the same title, then I can just compare, my every employee salary to that. So this inner part of it, right, which is basically you find the title. There are 19 possible titles you can get, and I mean, I do see that you did the sum of it, and I'm going, not so sure why you need the sum and why you need the number of people there. Really, the essence of the assignment is just figure out the average. So I would actually comment these two out and say, if I have for each person, if I can just figure out for the title, the job ID, and the average salary, that's all I pretty much need up here, right? So if I pick the salary and I compare it to the average, and I'm effectively getting that what I need. I like that you're using the left join because, yeah, what if the employee doesn't have a job ID which is in your XY, your inner query, right? So I mean, this is for me is a it's 95% accurate. Okay, so if we were to run this query, yeah, so the output at a minimum should be about, for every employee ID, we're supposed to, so this guy, employee ID 206, makes 8,300, and compared to the average in the people with that title, I totally understand why you did it. totally understand why you did it because it makes for a better visual. I'm just trying to highlight that the key deliverable is what you have, right? So this extra level of calculation here, I'm just going to make a point that from a performance standpoint, it's an overhead that you don't need, right, to get to the final output. However, for the sake of our discussion, I could grant you that okay, you just want to show how many people are there, and then you can get a better sense of the output, right? So this is what you're saying, right? Which is you know there's only one person in that department, right? Where is that job IDs? Yeah. So if they make this and this is salary average, yeah, then it's 1 to 1. I get it, right? But for our discussion, you just need, and I kind of stress this point for two reasons, which is oftentimes you inherit uh, queries that are slow, and somebody would have written something, made some money, and just left, and then you'll be asked to go fix it. So, um, you know, just always keep that in mind. I think it's a very key a very good way to make impression in any company in a technical role, because in programming, the key thing is performance, right? How quickly does this thing execute, right? Um, and so I'm gonna always try to use that, drum that point in your solutions, right? But this is excellent. This is perfect. Like I say, the second one is much simpler, right? So that one, um, let's see. So the question was for every employee, find the salary relative to the min and the max, right? So again, if I look at this guy, employee ID 100, makes 24 grand. The minimum salary is this. So he's making definitely about 20% more than the minimum and making 40% less than the max, right? So that's excellent. All right. Let's look at Cyril. Cyril, can you talk? Still sound issues on your end? Okay. Um, but I do hope that this sort of gets the point across. I mean, my guide that I was gonna give, I kind of broke it down a bit more. So my approach was to first explore the data, right? Basically, what you did is, I said, okay, I have this table of employees. Okay, all right. For every employee, I know the job ID, I know the salary. So if I need to compare the person's salary to the average for the same job ID, then I need to find the average salary for everybody who has the same job ID, right? So which is basically what you did, right? So this piece of it would say, go figure that out, which is the email query. Then once I'm done, I'm gonna do an outer join with it to go and pull the person's salary and compare it to the average salary by job title, right? So effectively, it's really the same output that you got. It's excellent. I kept it to the bare bones, right? For this employee ID, I have this. Now, this is just a guide as to how you're going to solve it. So ultimately, uh, is there some cleanup you can do with this approach? Yes, I'm always concerned about two things, which is whenever you divide it by some number, you always have to be concerned about what if it's null, right? In this case, it didn't matter, right? Because, you know, what if it's zero, for example, at the base. In fact, null is actually not a problem. It's more about if you have a zero. If you ever get zero, then you have a problem because then you get an error. You'd be amazed as to how many production problems you see where it has to do with things like this, right? And it can cause major outages in systems. And it's just because somebody's dividing by zero, and the computer just crashes because it's like the server crashes because it doesn't know what to do with it, and the person who programmed it did not put a rule that says, "Oh, if you ever got this, then you should do this," right? So at that point, it just hangs. It doesn't know what to do with it. Okay. Does anybody have any question with this the solution that we just discussed here? Because Nana joined us. Okay, Emmanuel, I'm on the bridge. If you want to join the bridge, that's fine. The phone number. Um, yeah, Nana, go ahead. Yes. The second one. Exactly. Yeah. I mean, that's a very good observation. Especially, yeah, if this is a final report or an output you give somebody, yes, you definitely have to give that the column. It's a good practice to always have. And it's interesting. I have this one guy that I work with. You send him a report and he sees stuff like this. He actually can raise a lot of hell just for that, just because he's like, he likes to just bloviate. He just sends emails to the whole world, like this is the end of the world, like because of column. But some of these things you can avoid them. It's a good thing. So thanks, Lena, for pointing that out. Now, I think, yeah. So Emmanuel, I think I hear you on the phone. Just try to make sure your background is quiet if you can, as much as you can. And if you have to talk, just signal and then we'll talk. All right, cool. Excellent. So if nobody has any question, after the course, after the class, I'll send you guys the um, last time I tried to do it, I sent you an email with sort of the class, the session's artifacts, right? Um, I did see that a couple of you watched the videos, which is good. I encourage you to make as much time as you can to watch it. I'm still trying to make sure that the quality is good. So um, definitely would like your feedback as to what can be done better in terms of the recording. Okay, now switching back to um, what is this? Let's stop the sharing here. And now I'm going to share Google Chrome. Okay. And let's switch this guy to this guy. All right. So both sessions are showing the same thing. Recording is still in progress. Okay. Um, as I said at the beginning, right? I mean, the outline is we're going to review the homework, right? We just did that. I'm really happy with what I saw. Cyril, um, I think your sound is still not good, right? So I'll review yours and I'll give you feedback. But my hope is that you're able to see the key points out of this, right? And since I didn't get a solution from Emmanuel or Nana, I presume that you guys think you know everything. So all right. Anyways, that's not to be piss anybody off. It's just to make light of it. But please try to spend some time to do these assignments because I really want you guys to have a lot of hands-on experience with this, right? Because you won't believe how much impression or strong impression you can make when you come for a job interview and somebody asks you a SQL and you can just whip it out, right? That hey, here's a SQL. Like, oh wow, this is awesome. You know your stuff. Okay, now I was gonna review what we did last time, right? With the architecture. I understand a couple of people did not really fully get it. So on my screen, I have sort of an image of what the architectural diagram is for Oracle 11G. We all installed Oracle 11G XE version, which is the Express version. The Express version is not the enterprise version. The key difference being its capacity is limited in terms of storage and certain functions or options, right? But for the most part, if a small company hired you to build a database for them or come and maintain it, or build a system that you need a database, the Express version would work. Yeah, as long as you're dealing with data less than about 20, 30 gig, you'll be fine. It's quite a lot of data. If you're gonna have to store 20 gig, that's quite a lot of data. Enterprise databases can support data up to petabytes, right? You're dealing with, if you work in a phone company or you work in a bank or any of internet service providers or any of these, Amazon, big companies, they deal with tons and tons of data. So they definitely need an enterprise version, and the enterprise version will have a lot of features to help you maintain your data. So last time I showed you this diagram and I said there's a lot of pieces to this, right? And I said think of this as just the architectural diagram of the Oracle database, okay? And in effect, I was trying to use the analogy of a restaurant to help you try to figure this out in terms of how these are interconnected. Not to say that you guys cannot read this and understand it, but I've always found that it's useful to really sort of try to take these software concepts to say, hey, software was built or was introduced after they started building a lot of processes, right? How do you build a bridge? How do you build a shop? How do you build a mall? How do you build a restaurant? Those things were done way before they started creating computers, right? So um, the very essence or the very best practices in those industries actually underpin how you build software. And now, over the years, now it's actually the software practices that are now being used, sort of in the other industries. So, um, for an Oracle database, right, and I have to remark that this is an Oracle database architecture diagram. It will be very similar for SQL Server, which is the Microsoft one. It will be very similar for some of the other databases. However, this is just for Oracle, right? The key ones you need to remember that may come up in an interview. If somebody wants to really be fussy, try to test you, which you can get sometimes when you meet. Manu and I, used to talk about how you meet certain people from certain parts of the world when they're interviewing you. They want to show how much they know during the interview, so they may throw things out there that you know if you just know enough about it, it can shut the person up, right? And so that they can move on to the more relevant questions that they're supposed to ask you. But for an Oracle database, we have the System Global Area, SGA, and then we have the Program Global Area, PGA. I mentioned in the beginning that we'll be talking about PL SQL, right? For this course, for today's session, the second half of it. The PL SQL literally resides in this section of it. What's my diagram? This area, the Program Global Area, right? And within that, you have your user global area. So every user that connects to the database has a section that they are operating in. And then these, what I call them, cylinders or containers, they contain a lot of your data and a lot of control files or control processes. And I did highlight a point that Emmanuel, you were interested in, which was that there's a database listener, which is the gateway to the database. So in the case of a restaurant, you make a reservation, you step in the front, and they ask, "Oh, do you have space or not?" Right? And then if they have space for you, they will let you enter, right? And this SGA is sort of where almost all the food is being prepared and the seating available for everybody, right? And the servers are moving through, the chefs, the cooks, the waitress and the waitresses. All this stuff is happening. That's really effectively what's going on, right, with a database system. There's a person who's listening, the database listener. That's the one that listens for connections, incoming connections. So the moment I bring up SQL Developer and I try to connect, it quickly makes that quick round trip check. Do you have capacity to take on this new connection which is coming in? The listener gets a response, yes, all right, it will let me in. If it doesn't, it will typically give you an error that we've reached the maximum number of people there or the maximum number of connections that are allowed, right? So in fact, whenever you're designing any software system that requires a database, that's actually one of the key things that you have to program around, which is how do you think about the website like Facebook, where people are logging in all the time, or any bank software, any website really that it's a lot of people are going to be using this system. Databases can only take in X number of connections. They can't take infinite number or millions of connections. So there's a lot of architectural programming concepts that you use to manage these connections that are coming through. Because you cannot throw 10,000 connections to your database and think it's going to be fine. It's actually going to crap out, basically, for lack of a better expression. So um, that's what the listener's job is. Once the person is approved, the person gets an area, within the RAM. So when you start a database, last time I showed you, like if you have an enterprise database, in that one can easily be running on a machine with like, let's say 200 gig of RAM, right? And the database will basically hog up about 100 gig of RAM. And that chunk that it takes, it tries to load a lot of the information that's readily available. Again, if you think of the example of a restaurant, the person who is figuring out, hey, do you have a reservation? Should quickly be able to tell you yes or no, right? Do we have enough capacity? They should quickly be able to tell you yes or no. They don't have to go and count and so is there space or not. So the RAM of the laptop or the computer or the server, most of it, if you ever install an Oracle database on it, right? And there's actually a lot of flexibility around that. So you can actually configure or keep allocating more space on your RAM to the SGA, right? So that your database can perform faster. Um, One of the concepts that has been threaded through most of these sessions is that the whole point of a database is to be able to store data, right? But it's very important that we understand that if we log in, let's say Cyril, you and I, let's say all five of us really have one bank account that we have access to, right? And I am logged in and I make a transfer or whatever, move some money somewhere. It would be useful that when you also log in, you should see that, right? So because if you log in and you see, hey, here is $1,000 that I can play with, right? And I've already transferred it out, we have a problem, right? Because by the time you do what you want to do with 1,000, I've already spent it. So in databases, the concept is commit, right, versus rollback. So whenever you make a change to a data record, you need to be able to commit that. Now that goes into where these cylinders are. There's a lot of interoperation between these containers that allows you to be able to recover your data. So when you update or let's say you insert a record, that record typically goes into sort of a temporary area. That information is available for everybody to see. However, before it actually gets written out to disk, it takes some time, right? It takes some time. So database, most of your data actually will reside on your online redo logs, right? Most of that information, once you write it, it just stays there on the redo logs. Meaning, it's like when you're typing in Microsoft Word and you want to do undo, 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 right? You can go back a lot of times to, let's say you made a mistake. It gives you the chance to go back multiple times. So that's actually what it typically does with your data. It will store it temporarily. That information is available to everybody. However, before it actually writes it down to the hard disk, it would, um, while that is transferring to you, the user, it takes a while for that to go to the hard disk. And that's actually important if you're a DBA, because you need to really be able to figure out, like, if the database server crashes, how are you going to recover your data, which is not fully committed to the disk yet, right? So, all right. So, like I said, the key things you have to remember is the SGA, System Global Area. That's sort of the main engine. Then the Program Global Area, the database, data and temporary files, the database listener, and all these archive files. All the other squares around them, these sort of like space management coordinator, memory manager, these are all things that are running on the database when you start it up. They run to monitor the performance of the database. They run to capture what activity is happening. So if you connect to your database, every single action you take, you insert a record, you delete a record, you update a record, the exact SQL that you wrote, everything gets stored. Every single action you take, the database records it. And that's actually very important, right? Because you always need to know any system you build, you need to have an audit trail. Who did what time, and what did they actually do? And if I have to recover, how do I go about recovering that, right? One of the neat features, and that's if you ever go for an interview, this is just sort of an FYI, is it's a very nice thing Oracle did called the flashback recovery area (FRA). Um, Prior to 10G, you didn't have that feature. So basically, what they've done now is, let's say an hour ago, right? I deleted a bunch of records from a table, from the employees table, and I realized, oh man, I shouldn't have done that. Now, once you delete it, it's gone. Okay. So how do you go back to it? So what Oracle does with the flashback recovery area is it allows you to restore your data back to a point in time. So you can tell that, hey, Oracle, go to the employees table and use data as of 1 hour ago when you are processing my query. Okay. It's a very, very neat feature. Like it saved me a lot in my work over the years, because sometimes you make a mistake, you delete something, you come and you're, oh shoot, how do I recover this? And back in the day, it used to really be a lot of headache, but because then you have to call the DBA has to go to backup tapes, and the DBA will say, well, I need 24 hours or 48 hours. Meanwhile, you probably don't want your boss to find that out, right? So if they have to wait 48 hours and create a service request, then oh my goodness, then all the big shots gets copied and notified. It was a pain. But with the flashback recovery area, you can just write your query and say select star from HR.employees as of timestamp 1 hour ago, or 2 hours ago, or 3 hours ago. And Oracle will give you the exact copy of the data as of whatever time ago. In fact, it's so precise, it can give you up to the microsecond ago. In fact, it's actually these days, um, it's actually microsecond. I don't know if they've gone to the nanosecond yet, but it's more, I remember it to be microsecond. Okay, that's what this flashback is. I've Every single interview that somebody comes to talk about Oracle, I've heard them ask that question: what is a flashback recovery area? Oh, it's just an area. It's just a feature in Oracle that allows you to recover data up to a point in time, right? On a table level, and that's very important. On a table level, and they may ask you, so what's the difference between the backup the database have versus that? Well, the backup you have is for the entire database with all that data. But on the table level, I just need employees table. I don't care about all the other stuff, just the employees table, right? Just restore that data using that. I can give you an example, but it doesn't really help in terms of where I think our focus should be in terms of time, right? So we are halfway through the session. So if folks don't have any question, I'd like to switch to the topic du jour. Any questions? Emmanuel, can you hear us okay?
Yes, I can hear you.
Okay. All right. Cyril, can you hear me? All right. Okay. So you don't have any questions. Perfect. All right. As I said at the beginning, right? Today we're going to talk about PL/SQL, right? PL/SQL is what we call procedural language SQL. Now, just how many of you have programming experience? So has anybody programmed in Pascal, C++, C, C Sharp, Java, Perl, Python, Corn Shell, whatever, does anybody have any programming language? VB, VBA? Okay, so do you have any experience in any? No, okay, no. All right. What about you, Andy? Okay. And okay. And what about you, Emmanuel? Emmanuel, what programming languages do you know?
I don't know anything.
Okay. All right. Nana, I knows VBA. Nana, what other languages do you know? All right, we can hear you, Nana, if you're talking. But I'm actually asking this question because this part of it, like I said in the intro of the session, was SQL as it exists, right? It's about querying for data and inserting data or manipulating data, right? So I in those assignment that said, oh, go and find for every employee how much they make relative to the average salary in their department, for example. That's the query you're going to write. How the data actually got into the employees table, how that was populated. Remember, we did that where we can import a file, right? In SQL Developer, we would create a CSV file during the project, and then we'll import it, specify the columns and all that. We'll create tables, all that good stuff, right? It's typically very static operations, right? Which is to say, all right, I've created some table, I've inserted data, now I've written a query. But oftentimes, your job as a developer is not like that. Your job as a developer would be, all right, there's this report that you have, okay? There's some data in some table, and some data in another table. And every day, I want you to go and read some value in this table, apply it to some column in another table, and then once you have that output, I want you to let's say create some CSV file, and then once you have the CSV file, I want you to read it, and then once you read the only person in this conference. All right. Once you read the CSV file, I want you to do this, right? What that means is that oftentimes, uh, writing a SQL is not enough. Writing a SQL can just create some results that we saw in the assignment, for example. But if we have to automate that process of saying that, um, you know, every day write this query and send a report to Mr. CEO, right, or Mrs. CEO, that's not something that you can easily do. Now, the beautiful thing about Oracle and as it has evolved is that, as a matter of fact, if you just knew Oracle, you can actually use it to do a lot of programming things, right? Unfortunately, uh, they were late to the game. When I say Oracle, they were late to the game in terms of making their software do some things that typically a programmer needs done that they will write like a batch script or a VB script to do, right? So now who knows VB, I'm sure you're probably familiar with the idea that somebody may have some, process and they want you to click a button. And when they click it, they're supposed to go pull data from some system and pull some data from another system, merge it together, massage it, and run some computations, and then output the report, the result to some Excel file or whatever. Right? That's all well and good. However, I mean that's one function. The other function is that sometimes when you're given a problem to solve in a query, you find out that it's not, you cannot just write a SQL to do it. What do I mean by that? It may be that you actually have to create like an inner query, but that inner query result actually has to be stored somewhere physically in the database. And then you have to go in and do some operation on it. And once you've done the operation on it, then you can try to read the data. I'll give you an example where, let's say you've been asked to, there's some, uh, you have a table with a million records, right? And you're trying to do some cleanup. And you're finding out that you're trying to delete the data and it's taking a long time, right? Now, I talk about if it's partitioned, then you could probably, it's very easy to clean up the data. But if it's not partitioned, you'll find out typically it's easier to export the data set out to a temporary area. Just export the records that you need, and then wipe the main table clean and put the result set back. So think of example as, okay, I have a million records in the table, and I'm really only supposed to keep 50 records. If I just write a query that gave me the 50 records and I kept it in some temporary area, delete and then instead of a delete, run a truncate, which is another command in Oracle, it will just get rid of the data. Then I can put my 50 records back into the table. Right? That's something that it's not a matter of just writing a query per se. Right? So as you go through PL/SQL, you would see how important it is. Well, if you have a website, now oftentimes you guys, I'm sure most people are familiar. Like you go to a website and you run some report. Let's say you need to find a history of all your purchases, right? Um, on Amazon, right? For those of you who shop online a lot, you want to find out the history of all your purchases on Amazon.com. You log in, and then you click order history or something, and it will show you a bunch of your orders. What Amazon actually does behind the scenes, sometimes a lot of PL/SQL, right? They may not use Oracle because they actually have their own database infrastructure, but effectively, what they will do sometimes they'll fetch a raw dump of your data into some temporary area, and then as you navigate through it, it will pull just the result set that you need. So think of it as if, let's say, your result set is you've for some reason you've made a million purchases, right, on Amazon over the last 10 years. They cannot show you all 1 million records on the screen. It will crash the browser, right? The browser just won't be able to respond. You see that your Chrome or your Internet Explorer or Microsoft Edge browser will just crash because it's just too much data to display. So, if you design a website, that's one of the things you keep in mind is if my result set comes back, I need to only show what is reasonable to the user. So typically for most users, they want to see about 25 to 50 records at the max, right? So maybe your query came back with your million records, so you have to store it somewhere, okay? And then as the user clicks next, or click maybe go to page this of my result set, then you can show them, you keep referring to it. This particular concept of software design is very important, which is oftentimes we have a lot of data we have to deal with. We run a query, it gives us a bunch of data, and we have to kind of step through the data in some sequence, right? And that's where the PL/SQL comes in. Because PL/SQL will give you the chance to step through something procedurally, right? You take okay, let me do this, let me do that, let me do this, let me do that. Okay. That example I gave you about a website is very, very, very important. Why? Because most I don't know how many of you are familiar, so let me just take a quick sidebar, right? When you write code for a website, you visit Facebook. Facebook actually has web servers, right? That's different from your database server. Your database server is also another server, just like your laptop, that's just hosting your database. You see a dark screen, Emmanuel, you said? Um, it's an outline, it's like a presentation. Let me see. Do you see core concepts? No, no. Yeah. Okay. Right. So let's talk about this example of a website, right? So in a website, you have a web server, and then you have a database server. There are other things in between, but for most part, it's called a three-tier design. The user that goes into the website logs in through their browser. They log in, and you give them. That request goes to the web server, and the web server says, okay, you want to do this? Let me fetch some of the data you need from the different databases that I'm doing, I have to do the work for. The web server is separate from a database server in a number of ways because the job of the web server is really not to deal with lots and lots of data. His job is mainly to deal with sort of, all right, Nana has logged into this site. Nana has a lot of data from in some Oracle database I'm supposed to connect to. All right, Nana, what do you want to do? You want to see the first 50 records? All right, let me submit a request to the database. Show me the first 50 records. Right now, oftentimes, you know, if you design it that way, every time that you want to see the next 50 records, you have to run the query again. So imagine that the query takes about 1 minute to come back. So once you click, it takes a minute for you to show the first 50 records. You click next, you have to wait another minute to see the next 50 records. Next, another minute. That's very frustrating from a user standpoint, right? So what PL/SQL gives you is the concept of a cursor, right? A cursor is another construct or concept within procedural language, which is a way of storing data that the user needs in the database server itself. Um, Again, I'm highlighting this to point out the core concepts, right, of PL/SQL and why you need it. Because sometimes you have to leverage the infrastructure you have correctly. So you have a database server, you have a web server, and you have the user. The web server is not the web server's job. And I've seen this because I've done a lot of web development over the years, where people will be trying to process a lot of data on the web server, and the web server will just crash instead of using the database, right? So anytime you have to build any system, you really try to put a lot of your database operations, data manipulations on your database server, because typically database servers are configured very differently. In fact, if I have a database server and I have, let's say, 32 gig of RAM on it, my web server may just have 8 gig of RAM and will still do the job, right? The database is the one that would do most of the heavy lifting, right? Okay, as I said, we're going to use one link. This link is a very useful link. It's not, in the interest of full disclosure, something that I put together. These guys, I've used them as a resource over the years. So they have a little history about PL/SQL. I don't want to get too much into this. Bottom line is PL/SQL is a free add-on on your Oracle database. So once you install, all of you have Oracle installed on your server, on your laptop, and with that comes the option to be able to run PL/SQL. You used to be able to pay for it in the past, okay? But it's kind of a pointless exercise now for them to charge you. So these ideas of operators, right, or concept of operators, is something we use to addition, subtraction, multiplication, division. These are all just signs you use for them, right? So, but if you have to use it in the PL/SQL, the structure is something like this, right? So if you have a variable called the salary, and you want to take that salary and add 5% to it, basically give the person a 5% raise. This is how you will write it in the PL/SQL, right? Right? And then if you wanted to figure out what the person's after tax wage is, this is how you write it. Now, the reason why I was curious to see people's background is if you have some programming background, this stuff shouldn't look foreign. And if it is looking foreign, which I can understand for someone like Cyril and Emmanuel and Andy, just bear with me for a second, right? We'll do a couple of examples for you to see how this whole thing works. But in PL/SQL, basically, you can declare a variable, and a variable, when you declare a variable in programming, it's basically saying, I need you to store some information for me temporarily because I want to do something, right? Um, in one of the earlier sessions we had, I tried to show you a diagram of how a computer actually processes 1+1, right? Which is it will take the one somewhere, it will take the plus sign somewhere, it will take another one, and then it will say, okay, let me take one. Plus means okay, where else do you want to read the next one? Oh, one here. 1+1 is 2. Let me store it here. So it will store the one somewhere. It will store the plus sign also another place, and then it will store whatever. So I think I use this example of this one. I was trying to show you that if I have to do 1 plus 1 equal to 2, it will first store, variable, in C1, it will store the 1. In C2, it will store the 1. And then C3 is actually your 1 plus 1 output. As a matter of fact, it actually uses four spaces because it actually also has to store the plus sign too. So in a much more technical sense, it would be something like, let's say plus. Okay. If you think about it, yeah, it won't allow me to put the plus sign, but let me just put plus here at the type. Right. So I'm trying to add 1 and 1. It's using like four memory addresses, right? So every time I have to declare a variable, right, to do something, anytime I have to do something in a program, I have to store something. That is a very fundamental thing about programming. We talk about Python, C Sharp, every program, Java. The idea of storing data in a variable is fundamental to it. Okay. Any questions so far? All right. So moving on to in PLC call, if I want to declare a variable, I'll just say I have this variable v salary, and I'll give it a data type, right? But these functions are operations that you can run, plus, subtraction, they are what we're used to. The one that I always find interesting that I have to remember is the power, like 2 to the power 5 or 3 to the power 2 or something. That one you have to use two stars. It's kind of like different programming languages use different methods. PLC code uses 2 stars. Okay. Then there is the order of precedence, board math. This is used from I think you're working from Ghana, so they call it board math, right? Brackets, divisions, multiplication, addition, and subtraction. The same concept. I think in the US they would say, what times they use? They call it um, PEMDAS, right? So parentheses, exponents, multiplication, division, addition, and subtraction, something like that. Same concept, really. The only thing that I think they have that we don't typically have is the exponent, right? So exponents are always they take precedence over multiplication. So that's what these are. Um, Andy, you're messing with me, so I'm going to take my control away from you. All right. So that's the order of precedence. Basically, when you're doing something like this, right? This is something we know, right? This is 8 plus 9 times 4. It will do the 9 times 4 first, right? Which is 36. It'll add it to 8, that's 44, right? You guys remember dual, right? So anytime you want to do an operation, you can use dual to help you get to that very quickly. Um, so basically, this is they try to highlight the example of how you do that, right? General comparison operation, greater than or equal to, less than. It's sort of the same concept. The only thing I'll tell you to pay attention to is equal, right? So for the people who are VBA, right? Equal, I think in VBA uses two equal signs, if I remember correctly. Other languages may use one. Other languages may use actually for you to spell out equals. Just different ways, right? In here, they use just one. And then the inequality is something not equal, not, right? You can use this guy. You can use that. Generally, what I see consistently across most systems is this guy, the exclamation mark and the equal, and then this guy, these two, not equal. Those are very common. Like I said, it depends on the platform. So if it's a very old platform, somebody may see these two, but in my honest opinion, I've never seen these in my professional life yet. Um, Maybe somebody's trying an old system. So these show an example of if your salary is greater than 40,000, then do something, right? That's sort of how you would do a comparison operation, right? So here, V salary is a variable that you have. Let's say you declared it, you stuck some number in it, and you're going to do a comparison to say, is it greater than some number? And if that's the case, then do take some steps. The three dots here, or the ellipses here, is simply saying, I'm going to write some code to do something, right? In our world of the data we are dealing with the employees and table, it could be that, oh, if the employee has served more than 5 years, then automatically increase their salary by 10%, right? So that can be some program that is already there. And then every day wakes up and it makes these adjustments automatically. Um, Nobody has to go to an Excel spreadsheet to do it, right? So then there's the string concatenation operator. That's basically if you have two strings and you want to put them together. I don't know if I think two sessions ago, Nana, and I think Andy, we talked about that example of combining the first name and the last name of the employees. This is the concatenation operation. So in VBA, right, I have the new string, variable new string, and I want to store two strings. I want to combine them together. The first string is variable string one, and the second one is this guy. All right. Then we have date operators. So if you have a date, the column has a date, like the hire date, for example, you can do some subtraction. It's very interesting how Oracle actually works, which is it actually is coded to handle dates very, very well, unlike most other languages. So in most of my professional experience, whenever I'm writing code that has to deal with date manipulation, I always do it on a database level because I find it much easier. In fact, Python is probably the one language that I find, since it's relatively new, um, it's actually not that new, but it actually does date operations very, very, very well, right? So, but generally, so something like this, where you're saying, I want to store tomorrow's date, you declare a variable called variable tomorrow. Sysdate basically means give me the current time on your system, right? And it's important because if you're in Ghana, for example, your sysdate will show the Ghana time, right? Because your laptop is or your server is configured to use Ghana time, which is GMT, I guess, right? You say add one to it. By default, if you take the date and add one, it actually adds one day to it, right? By this addition of one, that's what I mean. It's actually very simple. It's very intuitive. Take the date and add one day to it. In other languages, you actually have to add 86,400, which is the number of seconds that one day has, right? So um, it can be quite annoying, or it can be quite useful to use to outsource your data operations to your database. Going back to the layout, I mean, I've sort of touched on the operators, and the next one will be the types. I basically follow this layout, right? So when we talk of types, right, what do we mean by types? Let me go back to the spreadsheet I had, and um, we have to, I'll take a step back and sort of try to highlight this point to you guys. If I need to store an integer, right? Now, most of you know if you have a 32-bit machine, which we no longer have, right? Because now everybody has 64-bit machine, right? And this is when you buy any laptop, you'll say 64-bit, right? It actually can store. So this is 32-bit machine. This is a 64-bit machine. A 64-bit machine will be able to store to 64. Now, in effect, if you use this, you can store numbers. You can store numbers from negative 2 point whatever million, whatever billion, or I don't know how to pronounce it. 2.1.4, yeah, 2,147,483. All right. Versus this one is, I don't know what this is. This is like quadrillion, I guess. Because trillion is 12, right? And the next is quadrillion, which is I think 15. So whatever, XMB, I don't know, some huge number, right? In fact, you need a 64-bit system years ago to operate in Zimbabwe currency, the way the currency was devaluing. Most of the time when you're dealing with systems, right, and you're dealing with money, and you're dealing with operations, you have to really be cognizant of what you're trying to do with your data. So if I'm storing, um, salaries in the U.S., right? I can imagine that, you know, let's say there were no decimal places in the salary, then an integer probably makes sense, right? Because nobody's really going to get paid more than 2 billion a year. I mean, for people who are worth hundreds of billions of dollars, they don't get that big of a salary actually. But if I'm trying to capture their net, what do you call what, um, their net worth, then I probably have to do the 64-bit version. Why this is important is that if let's say you're going to do an operation like let's say 1 plus 1, right, which is 2, you need to really know what will happen if my number was to exceed the maximum capacity. So in your data, in your computer, when you say that I want to use this space here to store, um, I want to store some number. It would ask you what you sure you want to store a number? Are you sure it's not a decimal or anything? So if you tell it it's a number, then what did so if you think of this as your whole RAM, let's say this is your RAM, let's just demarcate this. Then it will take this piece and say, okay, Emmanuel wants to store some integer here. And since it's a 64-bit machine, I'm fine. I'm going to use this space to store that big number he wants to store. But if Emmanuel wants to store a string, right? Let's say here is I want to store 2000, right? But if I want to store a string like black, which is a string, um, it may say, okay, so you want to store a string here. So again, think of this as your whole RAM, right? If you want to store a string, the database, not your database, your laptop or your server has to make enough space for it. In fact, they may actually say, oh, well, since you can type it, somebody's name can be very, very long, instead of just using this, I'm going to use that. What am I getting to with this? So if you are trying to declare a variable to store an int, you will probably say something like v int number, okay? And then you could say, well, I plan to store numbers no more than 20, uh, right? If you want to store a varchar, you say, I want to store a string, and it's going to be varchar2, right? Maybe in the case it's 4000 is the max for varchar, right? That data type in Oracle. So that's how you define your variable. Again, how this ties in is if you don't tell in fact, PL SQL is actually very strict about it. That anytime you declare your variable, it asks you what data type do you want to use. Other programming languages like Python, they don't. They're actually very lax, and they try to figure out what data type to use when you start running the program, which can be a little dangerous because then it ends up eating up too much of your memory. But Python is actually very smart about it. But PL SQL and most other languages, when you are writing your code, anytime you have to store data, it's going to ask you, what data do you plan to store in this area of the memory that you want me to allocate, right? So that's the point you're trying to make here, which is if you have to store data, there's a number of types that are there for you. There's a bunch of them that is standard, like number, char, varchar2, boolean, right? Boolean is yes or no, true or false. There's binary integer, which is very special, very very efficient way of storing binary integers. Then there's PLS integer, one of the fastest way to deal with integers in an Oracle database. And number can store all kinds of numbers, like decimal places and all that good stuff, right? PLS integer and PLS integer, they're very specific to creating um, very efficient spaces that you can use to store integers. Then there's long. Then there's long raw, date, and timestamp. These are all standard data types that Oracle gives you. So you don't have to say, oh, if you have to store a variable that you know is going to be any of these types, you just use them, right? So like I was showing you in this example, I don't want to use a number. I just say number virtual two, I'll just say virtual two. But what if I want to store some object where the object is a car, right? So the concept of object-oriented programming language, if you guys remember, is that as programming evolved, it became important to be able to store things as a unit. So if you think of your employees table, right? I have employee ID, I have employee first name, right? I have their last name, I have their salary, I have whatever their job ID, I have some other attributes, right? This is stored in an Oracle table, right? And so if I have employee ID 123, first name, Kofi, ID, and the salary is 12345, and the job ID is Watchman, right? Point of it is that this record exists as one entity, right? In your HR.employees table, right? The one so what we working with. But if I have to manipulate this employee, how do I actually store that in a data in my program, right? And that's where an object as a data type comes in. Because remember that if I want to store a number, it's here. If I want to store a string, it's here. But if I want to store an object, I may need a contiguous block, let's say, which has that information, right? In fact, string is an object, right? So most programming languages is an object. So if I want to store my car, I may need an example of a car I have. I may need this block, right? Or in the case of the employee, I may need to say, okay, I need to store. So the way we do it, we'll say, okay, employee ID is 123. Their first name is Kofi. The last name is Ajay. Their salary is 12345, and then their job ID is Watchman, and whatever, right? Whatever attributes are there. The point I'm trying to make to you is that this unit exists as one from the database perspective, right? It's one. It's one object, and it says I have this area in memory which is referring to a person, an employee of this company. So when you're running your program, and I'm trying to highlight two things. The data you store in an Oracle table, that is actually data which is on a hard drive. It's persistent on a hard drive. Now, when you're writing a program to manipulate your result set of a query, that result set of the query gets loaded up into the RAM of your computer. It gets loaded up into your SGA, right? So this user gets some space, and as the SGA will talk, these two things talk, the SGA and the user program area, they will talk and they will give you some space for you to do your operation. Understand that this SGA thing here and PGA is all your RAM, the RAM on your laptop or your server, right? So that space, let's say this is all it is. Let's say the SGA was using all of this, is going to have to allocate this for just this object, right? That you're trying to deal with. So if I want to create an object of car, I would say v object car. Now, car is not a standard data type because remember the standard that comes with is this number, char, and whatever, right? There are other data types which are like let's say unstructured data. They are very large, CLOB, NCLOB. Like if you have a file, a zip file, or an image file, or those are whatever, right? They're huge. And if you have a table or record type, you have these. What we are referring to here, or the type I'm referring to is your own custom type, right? So that's one of the most powerful features of object-oriented programming, the ability to create your own type of data, that the computer must recognize, right? As outside of the standard that it comes with, right? So this stuff I'm explaining, I can see why it may be a lot for you guys. Um, so if let's say you're struggling to understand it, please, it's okay because you need to have some programming background, at least some basic programming background. But if you endeavor to understand P or SQL, believe you me, if you start learning Python or C Sharp, they'll be so much easier to understand. Um, the key point I'm trying to address is this: the program that you're going to write that will do some series of steps every morning, it needs space to work, and that space it's going to work with is the RAM, right? So in your server, you have to have enough RAM for the operation to work. But it doesn't mean you give it unlimited amount of space. If you don't run your program well, it will never come back. Okay. So I'm just gonna highlight this again. Let's say this was our integer data type, or in this case, let's say number to be specific. And this yellow one was varchar, right? So I guess use a color code here. So say green is green here is our number type, and yellow is our varchar2 type. There's no varchar3 by the way, just varchar2. It's a very interesting history. Why they have that. And this is my custom object type. Okay, custom object type. In this case, is a car. It could very well be a user, right, as an object. Okay. In fact, when you log into any website, one of the core objects that with a website program is using, like PHP. I don't know if you guys heard of PHP. PHP is a programming language using 80% of the websites that you see. One of the core objects it creates a user object. So as soon as you log in, it will quickly pull, okay, this user has his username, this is their password, this is the last time they logged in, this is what they did, the website, their location, their web address or the IP address. It stores all that information. And so that as you're logged in, it's not always going to ping and check, oh, who's this person who's doing the work? The first time you log in, it loads all that information into memory, right? And that memory, you know, will keep this memory whilst you are logged in. As soon as the session times out or you log off, it will just give back this memory back. The RAM will just have access to it again. It will just zap it, and then somebody else can use that. Okay. All right. I'm gonna try to wrap up within the next 10 minutes. Just go through some of the key concepts here, right? I've given you guys this link, and so you can try to read it at your own time. Like I said, I'm going to use half of next session to finish up the PL SQL, and then we would continue with our project. And as we do the project, some of the concepts that we've learned, we're going to be applying them there, right? So we'll be doing a bit more PL SQL there, and then hopefully with the examples, the idea will become crystallized in your heads, right? So the concept of a type is it's a very unique, powerful feature that allows you to basically create your own data type that you want to use, right, in your operation, right? Um, One of the nice things, and this is really a very good practice, that anytime you're going to operate on data that is coming from a database, you actually don't specify. You don't say, hey, v. You won't say like v underscore inf. You actually will say v underscore type, and then you will try to pick out the type from the table itself. So here there's a table called books, right, and a column called title, and this special sign percent type will give you back the actual data type that is being used to store title. So if it's varchar2, then this whole thing translates to varchar2. But specifically, it may actually be varchar to maybe 100, which means it's defined to not store more than 100 characters, right, for the title of the book. Again, it's about efficiency. So if you know the title of the book cannot exceed 100, don't go and create a table with a column that says varchar to 4,000. You're basically wasting a lot of that space. Now, granted, Oracle is smart about it, and that's why you actually have varchar. It's called variable character. If even if you say varchar to 4,000, it would only use what you need, but it's still a lot of overhead. If you use char, right, char will actually take up all the space. So imagine you use char and then you say char whatever 4,000 or whatever, char 4,000. Every single row will be using that 4,000, even if it's all blank, and it just takes up your storage for no good reason, right? So then there's one other feature called row type, which is basically a very efficient way of saying you tell your program that, hey, go to the employees table, for example, and give me the definition of the row type. And what it will come back to it, it will say, hey, the employee table has the following columns. It has employee ID followed by first name, last name, all the columns. It will give it to you. It's actually a very useful way. So that, in fact, if you guys have programmed before, and Nana probably can attest to this, in most other programming languages, you don't have access to this level of information, right? You actually, as a programmer, has to define, okay, variable for employee ID, variable for their first name, variable for their last name, variable for their salary, variable for their job ID, variable for all these other attributes. You have to create so many variables. But when you're writing a program against, or when you're writing a program using PL SQL, it actually can reduce a lot of the overhead because the row type will just give you all the columns in one shot, right? As opposed to typing almost 11 times. So here he says, okay, I want to declare a variable called variable books record. And I want you to go to the books table and give me the row type. And that one shot here effectively returns you all the columns, right, in that books table, and it stores it here as a variable for you so that you can process all the book records in your table. Now, collections, um, you know, I'll kind of pause here. I'll kind of skip this section and just work through an example with you guys. Collections, we'll talk about it next during the next session. It's just ways of creating your own custom types. Then there's a case statement, which is this is how you control your data, how you control your flow. So you've been dealing with this before, right? Case one, right? I think Emmanuel, you have posted a question in one of the chat groups, right? So case variable grade. If it's A, then it's excellent. If it's B, then it's very good. If it's C, then it's bad. This is very discrete, right? It's saying if it's A, do this, as opposed to a range test, which is what you're doing here. If salary is greater than 40,000, do that. That's a range. If it's less than 1,000, do that. Um, if you actually have to do a range test using a case, I gave you an example in the WhatsApp group where you actually, there you wouldn't say case V grade. You actually would say case when V grade between this and that, then do that, right? That's the example I've given to you guys. Then there's a loop concept, right? Which is given a bunch of rows of data, how do I step through each one once at a time, right? So maybe I have a bunch of rows and I will start from one and I'm going to keep going till I process the 10th row, right? Which is basically keep looping. And as soon as you hit your increment, your counter hits more than 10, then you exit out of your loop. In fact, I think this is very similar for VB. For VB, Oracle is PL/SQL is a little this syntax is a bit archaic, and so some of the stuff you see here, other languages is similar, but other languages don't go this route at all. It's a little, but they do give you multiple ways to loop, right? You can do sort of a simple loop structure. You can do a for loop. You can do a while loop. All they're all doing the same. My general advice is learn one of them and stick with it for all your programming needs. Anytime you have to loop, use one of them. Uh, in some cases, like I say, if you go to work for some place and they have using people are using different, you just have to understand it. But in my experience, it's best to just pick one approach and stick with it, right? If you know all three, it's great because sometimes you actually find out that it may be quicker and shorter to use one versus the other. But rest assured that this this stuff is doing the same thing, right? These three loops are doing the same thing, right? One of the key differences when you have continue, right? So continue is useful if, let's say, when you're looping and you meet a certain condition, right? So for example, let's say you are waiting for something to, I'm waiting for the user to click that continue my session, right? So say on a website and it starts the countdown, 2 minutes, 1 minute, 59 seconds, 58 seconds, and it's going down. As soon as you click OK, it resets, right? So that's the structure for continue. And then there's sequential control. Yeah, it's not recommended, and I totally agree that it's there, but don't use it. As a programming language, every language seems to have the go-to structure, but as Nana you probably can attest, VB also has it. I hate go-tos because when you're stepping through your code or you debugging it, as you try to figure out if there's a bug, they can be quite annoying to deal with. We'll talk about cursors next week. I mean, next session, which is Saturday at 11:30, which is basically when you have a lot of data and you have to operate on them. That's how you do it. But um, Emmanuel, are you saying something? Okay, getting feedback. So uh, this is a very simple example of how PLC code works. So if if any programming language you do, they call like hello world, right? So I'm going to quickly share my screen and show you one example, and that will be it for the day, right? So let me share the Oracle SQL developer. Stop, stop. Okay, all right. Let me just switch that here. Switch. All right, so we're gonna do. Just want to show you guys how you would use uh, this sort of PL SQL construct, right? So this is called an anonymous SQL block, which is basically it doesn't really do. You don't have a name for it. It's just going to run one time and that's it. Um, so that's the structure of it. Begin, end, and all I'm saying is print this line. Hi Ma, I can write PL SQL. Okay. If I wanted to do a couple of interesting things I could say. Let me say variable, strength. If I can remember my SQL, varchar 2, whatever, let's say 4,000. And what's my data type here? Let me use number actually. I just do number. In number. This is varchar 2. So here's a variable I'm going to use. I'm going to say v string. Remember, this is how you assign. You say string, and then we say hi. SQL. And DBMS output line is like just like your functions like average, sum, and all those things. In the PL SQL world, Oracle gives you a bunch of functions, and it groups similar functions into packages, right? So DBS output is one of the packages that are out there, and it has a function that if you give it um, a string, it will print it out for you. So, okay. So if this is typed correct, when you execute it, it's gonna give us that, right? So, right, that's the structure of it. There we go. Are we good? All right. So, like I said, for the hello, Nana, Nana, go ahead, please. You have a question? No. So there's a lot we can do here. What I'm just trying to show you is there's just okay. Let me put a comment here, right? We on the Saturday session we'll get into a lot of this. So this is got an anonymous PLC code block, and if let's say you have a process that you want to run every day, right now this is just merely just outputting for practical purposes, nothing really useful for us, right? So, um, but let's say we wanted to, write a program that every morning will just output. Let's say, let me just do this. Let's do dbs output string. Let's call it. I wanted to output. Let's write a program to output um, counter. Okay, so we're working with actually this example where they had a function that was doing accounting. So it would be something like this. All right. So you pick this and you put that here. Right. So it's like a while loop is going to do some work and effectively when you run this program, right, it's going to start from um, let's say all right. And this here, and we highlight format. Okay. Oh, I cancel the operation because I have I less than 10. No, yeah, actually it's a bad program. Let me start with set I equal to 0 and run that. Okay. Basically what, before I run this, let me walk you through this. Basically what we're gonna do is we have a loop and we're gonna say that we're gonna start, we look at what I is, and if it's less than 10, we're gonna increment it by 1 and we're gonna output it. As soon as I becomes, you know, let's say we're 11, actually, if it's 10, 10 is not less than 10, then would exit out of the loop, right? So the way, from a practical standpoint, right, the way the application of this is, let's say you have, all 108 rows of employees, and you want to look through each one and say, for each person, when I see their salary, I want to increment it by a formula based on their job title. So maybe they may say people who are job title um, AD this, AD president, they're supposed to get a 5% increase. And those who are whatever it is supposed to get 2%, some formula they're using, right? Some promotion. So you would write a loop that would say, look through all these 108 records and for each one do this. That's sort of a very simplistic example. But the essence of it is the structure, much like we're dealing with SQL, where it's select from where, right? The group by or order by. But with PL SQL, your structure is going to be declare is only needed if you're doing anonymous, okay? And if you actually have to create a function, and we didn't do that today, then you actually give it a name that is better than this one. The essence of it is please memorize the structure. Not to memorize, but at least keep this in mind. Is that you begin and then you end. These two things, so you look at this sign here and this operation there, is what will drive your the execution of your program. These expressions within them, I'm gonna take you guys through it step by step for those because and please, I will beg of you that for Saturday, if you guys can read up the link I gave you before we come, it'll be really really helpful. The reason is there's quite a lot that we have to go through Saturday, right? And it would be very nice if folks have read ahead of time and they'll come back with questions because um, the class is running up, and we need time. Cyril has a question that can this be applied to inventory levels? Sure. I mean, if you have any uh, process, you need data, and you have inventory of items that you stock in a company, right? And you have to run a program that will constantly check how much have been sold versus, so maybe there's a sales data, right? And so as people are selling, things are being shipped out, you need to make sure that you know the actual count that is left. And that information is fed to a website so that when a user logs in, they can actually see that you actually have the item in stock, right? Amazon is actually very good. It's one of the best at that. They will never show you a product they don't have in stock or ready to ship to you. Other people will just show you that they have it when they don't. Um, so I just posted the link and please read it. And for our next session, we'll start and we'll just go over through that. But today's point was just to give you an intro as to how POSQL works and its power and why you need it. It's my hope that you guys were able to sort of get the concept. I won't give you any major assignment except for you to read the link that I just posted so that when we get on the next session, it will go back. It'll go pretty fast. All right. Are there any final thoughts or questions? I don't know if Emmanuel you're still there, but okay, Emmanuel, I saw your assignment. I will take a look and I'll give you feedback. Okay. All right. As we're about to wrap up the class, please make the necessary. As we're about to wrap up this, I guess this class session, intermediate SQL, please make necessary arrangements. Okay. To take care of any outstanding bills you may have. So If you have no questions, I'll wrap up the session and I'll post the recording. I'll send you guys a recording. And please do your reading up, and Saturday should be fun, right? All right. Thank you, and have a good night.